Okay. So thank you very much for the invitation. And so today I'm going to talk about content delivery networks. And so what I'm going to tell is taken from a course that I give for 3 hours or 6 hours. So today we have 1 hour, so I will just provide like a very small subset of the information, depending on the questions and how fast we go. So let's see what we will talk about. But the topic is content delivery networks. I would prefer that while I talk, we stop from time to time and we take questions and we discuss about together about what I'm going to tell, instead of just talking for 40 minutes and then asking questions at the end. So I hope it will be interactive. Otherwise, it will be less effective. I hope that you hear me well. I assume so. So today, the amount of information to be sent in the internet is huge compared to 10 years ago or 20 years ago. And just to give some, there are in particular moments in which we have to send a lot of information. I will give just 2 examples. Well, one is Game of Thrones. Okay, so when the new episode of Game of Thrones in 2019 was released, 17 million people were watching it in the very same day. So providing good quality for these 17 million users is a challenge that was never seen before. Another example is the debate between Hillary Clinton and Trump that was watched by 2 million people simultaneously. So not spread over a day, but all at the same time. And so we have to send 100 gigabit per second in the best case. So if we consider, just to give other numbers, if we consider YouTube, there are 300 hours videos that are added to the YouTube database every minute, and 5 million videos watched every day. So you see that all these numbers tell that providing multimedia content in the internet is one of the biggest engineering challenges of our times, we can say. I will discuss mostly about video because video represented, at least it was predicted in the past that 82% of traffic will be video in 2022. So I don't know how much of this is true now, but still we can assume that video represents most of the bits transiting in the internet. And so it is particularly important to find solutions to stream videos in an intelligent way. So a lot of data that I will report may be a bit outdated, so please forgive me. But I think the concepts are always there. So today I will just talk about, so I will not talk, there are a bit of, okay, I will skip a lot of, test. There is some echo. No, it's okay. Okay. Okay, so sending videos not only is very important because it represents most of the traffic, but also it's because it is particularly challenging, because videos are very users are very sensitive to quality of service, which impacts their quality of experience. And also videos have to be videos have to be adapted to the different devices that users have, different operating systems. So if I watch a video on a smartphone or on a big TV, the content that the provider has to send me is different. And so you need to do all these adaptations, et cetera, et cetera. So all these difficulties should convince us that, I don't know, if my mother decides to open a website for videos about recipes, but my mother cannot deal with all these engineering complications. So we need specialized solutions. And so we need also specialized companies that deal with all these complications. And these companies and these solutions are called content delivery networks, which is the subject of today. So to discuss about content delivery networks, we should first discuss about how they work. So, and today I think we will just talk about redirection mechanisms and that's all. But content delivery networks include also strategies for load balancing, caching, and treatment of videos, adaptive video streaming, and dealing with quality of experience that we will not see today. So just redirection, I think. So let's start from the simplest architecture we may think of when you want to send content over the internet. Well, the first thing we can think about is a centralized approach in which we have one server and we put all the content here, and every customer who wants to consume our content has to connect to this very unique server. Of course, you see that if you have millions of users, this is not feasible because there is no server that can support all these connections. And also we would require a lot of traffic in the internet, which is not feasible. So a more intelligent approach is to distribute the same content in different servers located around the world. And so each user will connect most of the times to the closest server. The advantage is that each user suffers less latency. There is less congestion because each connection is shorter, we can say. So it travels less, a smaller amount of links. And also each server gets just a fraction of load. So it is more feasible. And this is what happens today. So what I told you about is about the architecture. So now let's discuss about the actors of the internet. So we have mainly three actors: users that want to consume content, content providers who provide content like YouTube, Spotify, and in the middle we have internet service providers like Vodafone, Orange, which guarantees this connection between users and content providers. Now, internet service providers can be roughly divided into two categories: access networks and regional internet service providers. The access networks are the ones on which we are connected, we as users, and also the ones which are directly connected to the content providers. But in order to consume a content from a server that may be located somewhere else, maybe in another city or in another nation, we first need to connect to our access network, and this access network has to connect to other regional networks up to the access network of the content provider. And so in order to guarantee this connection, the access network, suppose Orange, has to pay the regional network in order to be allowed to send and to receive traffic from it. So there is money going on. Now, suppose there are a lot of users of Orange who consume a lot of videos from YouTube. Well, in this case, they generate a lot of traffic. In particular, they download a lot of traffic. This traffic has to cross the regional internet service providers before going to our access network. I hope you see my mouse. And so for all this traffic, our access network, Orange, has to pay a lot of money to the regional ISP. So of course, Orange is not happy with that. So the solution that we can think of to reduce this upstream traffic for which Orange has to pay, one solution is to deploy a web proxy. A web proxy or cache is a small server in which we can put some of the content that the users want to consume so that they take it directly from the web proxy instead of crossing the entire internet and instead of making Orange pay for this upstream traffic. So let's see how a web proxy works, and let's see why it cannot be deployed today. So a web proxy works like this. So on the one side, we have users with their browser. On the other side, we have a service provider. Let's call it MyTube. Okay, so a user opens a browser and he wants to download the video. What he does is that he sends a sequence of HTTP GET requesting chunks of videos. This HTTP GET go to the server of MyTube, and the server of MyTube replies with HTTP OK with the chunks of the videos. Now, if another user asks for the same video without a web proxy, so we would see the same thing. So it would be the MyTube server to send the video. But with the web proxy in the middle, we can reduce the traffic because after the first time the user sends a request, the web proxy can intercept. So the web proxy that is installed into the Orange network can intercept the HTTP GET. And when the MyTube server replies with the content, the web proxy can store it in its storage, in its cache, and then send the content to the user so that if a next user asks for the same video, the request will be intercepted again from the web proxy. And so the web proxy can directly serve the video without involving the server of MyTube, and so without generating upstream traffic. So Orange is happy because there is less upstream traffic, and so Orange has to pay less to the regional internet service provider. But this approach is not deployed anymore. It was for sure deployed in the 90s. Now it's impossible because of HTTPS. With HTTPS, what a browser does before downloading any piece of content is to establish a TLS channel, transport layer security channel. And then over this secure channel, the browser and MyTube will exchange encrypted information. So all the requests will be encrypted, all the content will be encrypted as well. So the web proxy, even if we install a web proxy, it will just see a bunch of bits, scrambled bits, but it will not understand what is the name of the content that is requested and what is the content itself that the MyTube server is serving. So a web proxy is now useless with HTTPS. And now most of traffic is HTTPS. Now, I mean, today is way more than 50% of traffic that is over HTTPS. So web proxy is a solution that doesn't work anymore. Is there any question? No? Okay. So now CDNs, content delivery networks, are like a set of technical solutions to make this concept of web proxy work even with this, even today with HTTPS. So let's see a bit of history of content delivery networks. So content delivery networks are a nice story because the idea was born in an academic environment at MIT, and then it became a very successful business. And now it is a business worth a lot of money, let's say. So the story started with a challenge that was proposed at MIT by Professor Tim Berners-Lee, who is one of the inventors of the web. And so in 1995, still not a lot of people had the idea that that could be the amount of information sent over the internet that we see now. Still, Tim Berners-Lee had this concern. And so the challenge he proposed was about how to find algorithmic solution and architectural solution to stream huge amount of information over the internet. This was the challenge. And a professor and a student participated to this challenge, in particular, Professor Layton and Danny Lewin. And after this challenge, they decided also to apply for some small funding for in an entrepreneurial competition, and they got $50K in 1997. And thanks to this more funding, they funded Akamai. Akamai is the first content delivery network in the history. So you see that this thing, that still Akamai still is one of the most important content delivery networks today. But they started with the student competition. Okay, unfortunately, after 3 years, the founder of Akamai, Danny Lewin, died in the 9/11 attacks. But still, Akamai continued to live, and now they make a lot of money anyways. So a content delivery network is a company, is an architectural solution in which the content provider, suppose MyTube, gives the content to the content delivery network, and then it delegates the content delivery network to send content to the users. So there is a first phase of ingestion in which the CDN, so I will tell CDN instead of content delivery network to be faster, in which the CDN ingests all the content, and then the users will consume the content directly from the CDN. So if my mother is the owner of MyTube and creates recipes, she just needs to deal with recording the videos and then give the videos to the CDN, and then she can forget about serving the users directly. So it's CDNs are like postmen of content in the internet. After this phase of ingestion, we need a mechanism for redirection, because users will connect to MyTube. They will type on their browser mytube.com. So they believe they are downloading content from MyTube. Under the covers, we need a mechanism in which instead the content, the requests of users are redirected to a CDN node without the users noticing anything. And so I will mainly discuss about these redirection mechanisms. Just to give a bit of ecosystem here are some names of content delivery networks. I took 3 content delivery networks: Amazon CloudFront, Akamai, and Cloudflare. You see that each one has its own client. This was some years ago. Now things have changed for sure. There are also So, for instance, LinkedIn uses Akamai to provide the website to millions of users. Facebook as well, et cetera, et cetera. Things get a bit complicated because the same content provider, like Amazon, can use different content delivery networks. For instance, Amazon uses its own delivery network as well as Akamai delivery, content delivery networks. This is done for different reasons. One reason is because you want to have be more resilient, to have a backup. So if the Amazon CloudFront doesn't work for some reason, it is under attacks, etc., at least Amazon has another content delivery network that will still provide content. Another reason is because each CDN can be more present in a certain continent, for instance, Europe, and less present in another continent, Africa. So if I am a MyTube, I may have some contracts with CDN number 1 in Europe and some other contracts with CDN number 2 in Africa, and so on and so forth. You need also to consider that now the big content providers like Facebook, they have their own content delivery networks. And they use their own content delivery network as well as third-party delivery networks like Akamai. So, I mean, the CDN ecosystem is a very complicated thing that changes all the time. We need to take this into account. But still, Akamai is the main player and also is the more transparent player. Let's say that they have a strong research group. They publish paper in which they explain their technical solutions. And so I will mostly talk about Akamai CDN solutions. So just 2 years ago, Akamai recorded its new web traffic peak. So at a certain moment, they were sending 200 terabits per second over the world. So you see the size of this. These are some Akamai's customers. You see, big content providers like BBC, Microsoft, Siemens, BMW. There are also governmental institutions, etc., etc. So Akamai is a big guy in the ecosystem of content delivery networks. So now I will start to go a bit more technical, and I will talk about this redirection mechanism that gives to the users the abstraction of connecting to MyTube, while instead, under the cover, they are downloading content from another node that is a CDN node. Before I continue, any question?
I think we are good for now.
Okay, so let's talk about redirection mechanisms. Let's talk first about the simplest case in which there is no CDN at all. So the classic case in which users download content from MyTube. So what happens is that the user type mytube.com in the browser. The browser will call a system, we'll call a system call. To perform a DNS lookup. This means that there is a process into the operating system of the user that will do some actions in order to translate mytube.com into an IP address. And in particular, this DNS client running into the operating system of the user will send a DNS query to the DNS system. The DNS system is a distributed system all over the world in which there are different servers located here and then. So, and the client of the user will send a DNS query saying, please give me the IP address of mytube.com. I will not go into the details of DNS, but what happens is that magically this DNS system will redirect this DNS query to the authoritative servers for MyTube. The authoritative server is a server handled by MyTube, which associates to www.mytube.com the IP address of the server that contains the videos of MyTube. So this DNS query will be redirected by the DNS server to the authoritative servers of MyTube, which will reply with an IP address, XXXX. So now the browser received, so the operating system of the user received the IP address. And so the browser can now set up a TCP connection with the IP address of the MyTube server. Then there will be a first phase of establishing a secure channel, transport layer security channel. And then within this channel, a user will send HTTP GET, that are requests for content, and the server will reply with the content itself. Everything here will be encrypted. So the first HTTP GET that the user will send is for usually the page, the home page. Usually it is index.html. So the server will reply with the HTML code of page index.html. Into this HTML, we'll have a list of videos, and imagine the YouTube homepage in which you have the the small images of videos, and behind each small image there is a link toward a certain video. How do you say vignette? So in French we say vignette.
It's an icon.
Icon, okay, yes, icon. I was looking for another term, but okay. Okay, so each icon corresponds to...
Thumbnail. It's another suggestion from the group.
Which one, sorry?
Thumbnail.
Thumbnail. Yeah, maybe this is the term I was looking for. So each thumbnail is associated to a link for a specific video. So suppose that the user clicks on the thumbnail of video A. This translates into an HTTP GET video A of the browser, and the server will reply with chunks of videos. This is a simplistic vision, but it's enough for the moment. Okay, this is not interesting. But now suppose we want instead to use a CDN. So we want to download the video from a CDN node instead from MyTube. So to achieve this abstraction, we can use three different redirection mechanisms: URL rewriting, CNAME, and domain hosting. Let's start with URL rewriting. In URL rewriting, everything happens as I discussed, except this part here. And I hope if you don't see my mouse, please tell me, because otherwise I will not be understood.
We see it.
Okay. So here, notice that when MyTube replies with its index.html, the links behind each thumbnail is modified. It is not www.mytube.com, but it's www.node1.cdn.com/video-a. This means that whenever a user clicks on this thumbnail or video number A, or video A, it will connect to the node of the CDN and not to the server of MyTube. Okay. So this is the simplest mechanism called URL rewriting. This is conceptually very simple, in practice, it is very complicated because now if my mother wrote this website called MyTube with the recipes, she has to deal with the HTML codes and modify each link behind each thumbnail. And she has to deal also with load balancing and she has to understand if a user is connected from Africa, then she has to provide an HTML page in which the links are modified with the node that is in Africa, the CDN node that is in Africa. If a user is connected from Europe, well, my mother has to send an HTML page with the node 2 that is in Europe, etc. But my mother doesn't want to deal with all these things. So this is why content providers, this solution is too complicated for content providers. So we need a simpler redirection mechanism. And a simpler redirection mechanism is based on this CNAME mechanism. It's called CNAME, let's say. It works like this. So as I told you before, the user writes mytube.com in the browser. The browser tries to translate mytube.com into an IP address. And so as before, the DNS system will redirect the DNS query to the authoritative server of MyTube. Now, the authoritative server of MyTube will not reply with the IP address of the MyTube server. It will reply instead with an alias. This alias will say, look, if you're looking for mytube.com, well, it is equivalent to cdn.com. So, and so the reply to the DNS client running in the user operating system will be cdn.com. And so now the operating system of the user will look for the IP address corresponding to cdn.com. So this, the query for cdn.com, of course, will go to the authoritative server for cdn.com, which is in the hand of the CDN. Is no more in the hand of MyTube. And so the CDN will reply with the IP address of one of its servers. So the CDN will implement the logic of considering the origin of the server of the user. If the user comes from Europe, it will reply with the IP address of a node in Europe. If the user comes from Africa, it will reply with an IP address of a CDN node deployed in Africa, etc., etc. And so now the user will take the IP address of the CDN, thinking that it is the IP address of the server of MyTube. And it will connect to the CDN, and it will be the CDN who will provide the HTML page, and so on and so forth. Everything else will occur as before, with the difference that now we are connected to the IP address of the CDN instead of the IP address of the MyTube server. So this mechanism is called CNAME because this DNS mechanism, or replying with an alias instead of an IP address, is called CNAME. So what is the advantage of CNAME with respect to URL rewriting? Well, it is that it is much simpler for MyTube. Actually, MyTube doesn't even need to deploy a server anymore, because there will be no direct connection anymore between MyTube server and the users. So this is a big simplification, big saving of money. So my mother doesn't have to install a Linux distribution and everything to to handle a server. She will just need to give all the content to the CDN, and the CDN will deal with everything. Of course, she will have to pay money to CDN, but most of the time, this is much more convenient than handling a set of servers deployed all over the world. Okay, so CNAME is another redirection mechanism, much simpler than URL rewriting. But still, look at this. So even with CNAME, MyTube has still to deal with authoritative name servers. So my mother still needs to know about DNS. She needs to install a DNS software to be able to reply to the DNS queries. So for my mother, it's too complicated. So she would like also to get rid of this complication. She would just focus on recording videos of stuff. And so here, the other solution comes that is called domain hosting, in which the authoritative server for MyTube will be directly the CDN. How can it happen? So maybe let's go back a bit on this thing. So whenever I am a content provider called mytube.com, and I want this, then my name, mytube.com, to be announced in the internet, what I have to do is I have to register this name, mytube.com. So I have to go to a registrar. For example, the registrar that is handling all the names ending with .com, and I have to pay to register my name, mytube.com, to register my name behind .com. And I pay, and I also communicate, when I register my name, the IP address of my authoritative server. Doing like this, every time the authoritative server for .com receives a query for mytube.com, it will know that it has to redirect these queries to the authoritative server of MyTube that was communicated at the registration moment. So when I use this third solution, domain hosting, when I register mytube.com, I will not communicate the IP address of the authoritative server of MyTube. I will communicate directly the IP address of the DNS server of CDN. Like this, all the queries for mytube.com will be going redirected to the CDN directly. So now my mother doesn't even need to install an authoritative DNS server. She doesn't need to do anything. She doesn't need to own even a single server. So she can provide videos to millions of people without having not even one server. Okay, is this redirection mechanism clear? Any question?
I think it's all clear.
Okay. Okay, so I told you about the redirection mechanism. There are advantages and disadvantages of each of them, but for sure we can say that URL rewriting is the most complicated. CNAME is a bit better, but still complicated because you have to handle DNS authoritative servers. Domain hosting is the very, very easy one and is the most used. Now, the most complicated part of this is server authentication, because so far we have assumed that the user wanted to connect to mytube.com, it receives an IP address of another guy, that is the CDN node, and it will accept it. But things are not so easy. Why? Because today, fortunately, when we connect to a website, the browser does some verification to be sure that on the other side, we are really connected to mytube.com and not with the site of another guy that is faking mytube.com. Okay, so today, all the browsers implement mechanisms for authenticating the server. So I will not talk about authentication of the user. This is another stuff, autonomous stuff. So authentication of the user is when I connect to Netflix, and Netflix want to know if I am a user that paid Netflix. This is user authentication. What I'm talking about instead is server authentication. So it's the problem of the user willing to know is if the guy who is replying is actually Netflix.com or some other guy that is impersonating Netflix.com. So how this server authentication is done? So the simplest, to describe it in simple terms, what happens is that the browser sends a challenge in the form of a randomly generated number to the server. And let's say the server has to be able to solve the challenge. What does it mean to solve the challenge? Well, the server has to own a pair of keys, a public key and a private key. The public key is meant to be known by everyone in the world, while the private key is should be private. So only mytube should know the private key. So when mytube receives this challenge, what it does is that it signs this challenge, this random number, together with its certificate. The certificate is a file in which there are some information about mytube, like the name, the address, and other stuff, and also the public key of mytube. So signing a certificate and a random number means to perform a mathematical operation and using as parameter this private key. So to sign something, mytube needs the private key. So mytube will reply to the browser sending the certificate as well as the signature. And the browser can verify if the signature is correct or not. So to do so, it performs a mathematical operation that I denoted here with sign -1. It's the inverse signature, let's say. Applying this time the public key of the server. The result should be the certificate and the random number that the browser was sending at the beginning. So the magic of asymmetric cryptography is that this inverse signature will succeed only if the signature was produced by the private key associated with the public key. So if an attacker that that wants to impersonate mytube, but of course he doesn't have the private key. So if this attacker tries to sign something, So of course, it will not be able to use the private key. It will use some other key. But, and it will send this fake signature. The browser will immediately understand that this is a fake signature, because when it performs the inverse signature, it will not recover the original information, the certificate and the random number, because the signature has been produced with this black key that is not the private key associated with the public key of MyTube. Any question on that? And yeah. And if not, I will ask a question to you. Okay. So why is it important that the browser, to make this mechanism solid, why is it important that the browser sends a random number? Cannot MyTube directly send a signature of the certificate without sending, without signing also the random number?
Well, nobody replies, so to make sure that you cannot intercept the reply from the server and replay it, right?
Exactly, because, yeah, exactly. So if there is no random number at the beginning, and MyTube just needs to sign the certificate to be authenticated, well, if there is someone listening to this communication, for instance, the network operator, it can store the signature. And so next time that another user is trying to authenticate MyTube, it can, the attacker can reply with the same signature that it observed before. And the browser will believe that it is talking with the actual MyTube. So we need instead a mechanism that forces every signature to be different. And so by signing every time a different random number, we force every signature to be different. And so signatures cannot be intercepted and replayed again next time. Okay. Thank you, Francesca. I don't know if I have time for that. Let me see. Okay, so now the problem we have is that the browser wants to authenticate MyTube, but actually we have redirected the HTTP requests from the browser to another node that is the CDN node. So can anyone of you give me a solution to allow CDN nodes to be authenticated as MyTube? There is a very simple way that astonishingly it is still used.
We cannot think of it.
Okay, so it's this thing. So it's that MyTube gives its keepers to the CDN. I give the public key and also my private key to the CDN. So when a browser connects to a CDN node and it tells, okay, are you MyTube? The CDN node can reply, yes, you see, I'm able to sign in the name of MyTube because it has the private key of MyTube. So it's like MyTube is giving the key of his home to a stranger. This can be strange because it violates all the ideas about asymmetric encryption that is based on the concept that the private key should not be given to anyone and should be only known by MyTube. But still, it is what happens still today. There was a paper in 2017, and now I found another paper in 2022, which also verified how different CDNs work, and this mechanism is still in use. And what is the problem here is that if now, so I have to trust a lot the CDN, because the CDN now can speak in my name, and I have no direct way of telling the CDN, stop, you have no right anymore to talk in my name, because for the rest of the internet, CDN is now indistinguishable from MyTube. So these authors of these papers, they practically try to use a CDN service. They gave this pair of keys to the CDN, and then they said, okay, now let's try to revoke this pair of keys, and let's see how much time it takes to revoke, to stop CDN to use our keys. So they had to send emails, etc., etc. So it took 3 to 4 days. During this period, MyTube didn't want CDN to talk in his name, but still CDN was continuing to talk in his name. So you see the very bad mechanism where it is, but it is what is still used today. Any questions? No.
No, we are running out of time.
Okay, yes. So there are other 2 mechanisms to deal with this problem. So 2 minutes, 1 mechanism per minute. So I should talk about the certification authority first. Let's see how can I do. So, okay, in 30 seconds, I will say that all these certificates I'm talking about are issued by certification authorities. These are, let's say, trusted institutions in the internet that if you are MyTube, you have to pay in order to obtain a certificate that this certification authority recognizes. And so every time a browser receives a certificate telling the information about MyTube, the browser can verify if this certificate has been issued by a valid certification authority or not. And so it can see, it can check if the browser can trust a certain certificate or not. Okay. Having told that, I can talk about the second solution used by CDNs, that is this shared certificate. In this solution, MyTube doesn't need to send the pair of key to the CDN, but it does something a bit different. So, so the YouTube manager finds an agreement with the CDN, and the CDN tells, okay, now I'm adding MyTube to my own certificate. So the CDN contacts the certification authority specifying, please add the name of MyTube in my own certificate, in the certificate of the CDN, because a certificate can contain different names. So in this case, CDN is asking, in addition to cdn.com, please add in my certificate also mytube.com, because I want to also speak in the name of mytube. The certification authority will say, okay, let me see. It will contact mytube. It will make some verifications. And so it will contact mytube. It will talk on the phone to mytube saying, CDN is claiming that they want to add your name into their certificate. Do you agree? Well, mytube manager will say, yes, I know, I want that. And so now the certification authority will issue a new certificate containing cdn.com by mytube.com. So now, whenever a user wants to authenticate mytube, the CDN can reply in the name of mytube using its own private key and not the private key of mytube. So this is, you see, a bit better, but still CDN can impersonate mytube. And if mytube now doesn't trust anymore CDN, mytube has to call certification authority. It has to convince that it doesn't want anymore his name to be associated to the certificate, and so on and so forth. So it takes some days. It's not immediate. So this is why the third solution has been proposed. This is keyless TLS, and then I will stop. In this solution, this thing happens. So first, mytube still needs a server because the browser will first connect to the mytube server and it will authenticate mytube server. Then it will create a TLS connection with mytube server. And at this point, instead of directly asking for the content to mytube will send the temporary keys that are valid just for downloading one video, let's say, to the CDN node. This means that now the browser can use this encrypted session with the CDN node. The session was initiated with mytube, but then it was, let's say, redirected to the CDN node. And so the browser can exchange data with the CDN node using these temporary keys. But after the video download streaming is over, CDN node cannot impersonate anymore mytube because the temporary keys are just valid for one video streaming. So you see that this mechanism is quite better. It was patented by Akamai, but Akamai doesn't use it. Instead, it is used by Cloudflare, at least until 2017. But still, it's a better solution. Do you think that this solution is used more than the others? And then I stop. I stop with two questions. So actually, okay. The answer to my question is not really. So this solution is technically better because mytube, so CDN cannot now maliciously impersonate mytube even if mytube doesn't want. But still, it is not very used. Why, in your opinion?
I would say because you have all the load of the first connections on the server.
Right. Because my mother that owns mytube still needs to set up a server and maybe powerful servers because they have to reply to a lot of users, at least for the first phase of TLS channel establishment. So yeah, so this is why not all the content providers have the technical skills to do so. Okay. I will end by saying that I would say that still provided providing content in a very secure way over the internet is an open problem. The solutions that are used today are very weak. And interestingly, the CDNs sell their products saying secure service, secure whatever, etc., etc. And at the end, they rely on mechanisms that are everything but secure. I also think that this is caused by two issues. One is because there are no technical solutions that have been found that are easy to implement for content providers. The other is that the big CDN players profit from the weak mechanisms, because if a newcomer, I want to create a CDN and I want to enter the market, nobody, since all the mechanisms are very weak, nobody will trust me and give me their private key, or nobody will allow me to write in my own certificate the name of other content providers. I will not be trusted because I'm a newcomer. People will trust Cloudflare, people will trust Akamai, and they will even give them the private keys because they will think they are big players and they are trustable. But people will not trust the newcomer. So these weak mechanisms play a lot in the advantage of big names, which can exploit their trust. This is my personal opinion, but and with this I conclude.
Thank you.
Thanks to you.
So are there any questions here or online? Yeah, Francois.
Yeah, so could you say, I mean, a few words also on the quantitative aspects? I remember, I mean, when you have this idea of caching, I mean, when you have a miss, people have computed the chance of a miss. And I suppose when you have a hierarchy of these caching things, I mean, what are the things that people are doing now for these questions? How to populate the caches based on popularity?
Yes. So for this, yeah, I could do another tutorial on this only, but yes. So for this, there is a very interesting paper from people from Akamai who explain what they do. And there was a paper in 2012, but now there is an update on this paper. And actually, as you said, these so there are different problems. One problem is how to do load balancing among the different servers and load balancing among clusters first. So if I have a user here, should I let him consume the content from this cluster here, or this cluster here, or this cluster here? And so this is global load balancing. And then after you select one cluster, how do you load the load? Do you balance the load within the servers of this cluster? So global load balancing and local load balancing. So for global load balancing, actually what they use is a modified version of the stable marriage problem that I will not discuss, but okay, stable marriage problem is a problem where that is meant to solve to match two categories of objects. For instance, to match men and women. And so the stable marriage problem was proposed by economists who won also the Nobel Prize in 2012, or at least two of them. And actually, these people from Akamai, they said, okay, we will use the same approach. Now, for us, the men are the requests from users, and the women are the clusters, with a lot of modifications to make everything work. But yeah, the concept is this matching problem between requests and clusters. Then to do this and this is to do the global load balancing between clusters distributed around the world. And this matching is based on vicinity. So you will tend to give to associate each user to the closest cluster, but also on the cost for the CDN to provide the content, because the CDN is connected with regional ISPs and maybe with different regional internet service providers. And so if a user is requesting a content, I can pass by path number 1 or by path number 2. And maybe if I provide the content from cluster number 1, I will pass by a certain path and I will pay some money. The CDN will pay some money. Well, if I may prefer to serve the content from a cluster that is maybe farther away from the user, but that allows me to reach the user through a path for which I pay less. So there is vicinity that is taken into account, money, actual current load of the clusters, and all these aspects that are put everything in this matching problem. After I select a cluster, I have to select one or multiple nodes within the cluster, and for doing that, they use hashing. I will not go into the details. And this is just to understand to which node I should redirect users. Then I should also understand which content, which videos I should store in each location. And to do so, they use caching policies of different types. Actually, Akamai doesn't talk about that, but we know that there are caching policies of different types, reactive, proactive. And this is to decide which videos I should store in each node, in each cache node. And yeah, this would merit another tutorial. I don't know if I answered your question.
You did. Thank you. But yeah, for Akamai, they don't publish their policies, right? So.
I think in their paper, no, I don't remember. I don't remember. But yeah, caching policies there are a lot of paper on caching policies, and there are a lot of open source software that are used. Akamai in particular, I don't know.
Are there any other questions here or online? It seems not. I have one.
Yes.
A bounce back. Well, a bounce back to security, because your last slide made me think that if I'm using a service for which I do have to authenticate and I use it through the CDN,
yes,
it probably means the CDN has all my data as the legitimate provider. And this is necessary for delivering the service that I'm asking for.
Yes.
So do CDNs are in the business of using data the same way that Google or Facebook are? And if they are, this is the first time that this comes to my attention. So I think this is quite a thing.
Yeah, so if you go to the website, so I don't know if I understood correctly, but your question, but I will answer with my assumption of understanding of your question. So if you go to the website of some of these CDNs, you will see that they also offer services for the video providers to optimize the advertisements that they add in your videos, and also to profile your users. So my mother has this website, MyTube, for instance, and she doesn't know which category of people looks at this video. So she doesn't know how to make money by allowing the right advertisements to the right videos. So she can buy the service of the CDNs, who will profile the users and will deal with this business of attracting advertisement and insert advertisements in the video. So this means that, yes, CDNs can monitor the behavior of the user of MyTube.
Okay, that was exactly my question.
Yes, and it's not something they hide. It's something that they sell, because they say, we can study your users and we can tell you how to serve them better and how to get more money out of it. Now, if they use the profiling information of one service, of one content provider, also to improve the service of another content provider, this I don't know, but I guess so. If you understand that,
yeah,
if you serve MyTube and you understand that teenagers like a certain type of music on providing a certain service, well, this finding, I think you will reuse it also when you add the advertisement to the videos of another content provider. I think they do, but I don't know.
Thank you. So I think on this note, we wrap it up because we're running quite late. Thanks again for being with us today. And
thanks to you. I'm sorry that I couldn't be there in person. You know, I like to be in person, but I could not. But next time, I hope so.
We're looking forward having you back. Thank you again.
Thank you. Bye-bye.